Good morning, everyone. In this session, we are going to compare tropical dairying systems in India with those followed in developed countries. This comparison is part of dairy technology education and is important for understanding how climate, technology, and management influence dairy production. The discussion is designed for undergraduate and diploma students. To understand the relevance of this topic, let us first look at why tropical dairying systems need comparison. Climate has a major impact on dairy practices. Different climatic conditions directly affect animal physiology and milk production. Geographic factors also play a role. Farming systems evolve based on local resources and environmental conditions. Comparing systems helps in optimizing practices. By understanding differences, better management strategies can be designed. Cross-learning is another important benefit. Learning from both systems leads to innovative solutions for tropical challenges. Let us begin the comparison with climatic conditions. In India, dairy animals are exposed to very high temperatures, often ranging from 35 to 45 degrees Celsius. Humidity levels are also high, usually between 70 to 90%. These conditions lead to severe heat stress. In contrast, developed countries experience moderate temperatures, typically between 10 and 25 degrees Celsius. Humidity levels are moderate, allowing animals to remain within the comfort zone. As a result, thermal stress is much lower. Next, let us compare the level of technology used in dairying. In India, milking is largely manual or semi-mechanized. Traditional practices are still widely followed. Cooling systems are basic or conventional. Sensor-based monitoring and data usage are limited or mixed. In developed countries, robotic milking systems are common. Feeding and milking are highly automated. Management decisions are data-driven using IoT and digital monitoring. This leads to better efficiency and consistency. Another major difference can be seen in milk collection and handling. In India, milk is collected from villages mainly by small farmers. Milk is often handled in cans and transported under ambient conditions. Bulking centers and chilling units come later in the chain. This creates hygiene risks. In developed countries, milk is cooled immediately at the farm level. Insulated tankers transport milk directly to processing plants. The cold chain remains unbroken, resulting in high milk quality. Cold chain and refrigeration systems further highlight the contrast. In India, milk collection usually starts at ambient temperature. Cooling is delayed by 3 to 5 hours. Temperature breaks often occur during transport. Power interruptions also affect refrigeration. In developed systems, milk is cooled to 4 degrees Celsius within 2 hours. The cold chain is continuous and monitored. There are no temperature breaks from farm to processing. This preserves milk quality effectively. Infrastructure and management practices also differ significantly. In India, dairying is dominated by smallholder farms. Logistics are dispersed and fragmented. Power and water availability is often limited. Management protocols vary widely. In developed countries, farms are large and integrated. Operations are centralized. Infrastructure is reliable. Standard operating procedures are strictly followed. Animal comfort and housing is another important area of comparison. In India, animals are mostly housed in open sheds. Cooling depends on natural shade and basic fans. As a result, animals experience high heat stress. In developed countries, housing is climate controlled. Soft bedding, misting, and cooling systems are common. These facilities ensure optimized animal comfort and welfare. These differences directly affect milk quality and safety. In India, bacterial load in milk is generally high. Testing is inconsistent and often manual. Milk quality varies seasonally. Standards are not uniform. In developed countries, bacterial load is low. Testing is fully automated. Quality remains consistent throughout the year and meets strict standards. Economic and operational efficiency also show a clear contrast. In India, average milk yield per cow is around 5 to 8 liters per day. Operations are labor-intensive and mostly manual. Costs per unit are lower but efficiency is limited. In developed countries, yield per cow ranges from 25 to 40 liters per day. Operations are highly mechanized. Overall efficiency is much higher. This slide summarizes the key differences at a glance. India faces hot and humid climate with high heat stress. Technology use is manual or mixed.
Cold chain gaps are common, leading to delayed chilling. Milk quality is variable. Developed countries operate under temperate climate. Technology is automated. Cold chain is complete from farm to fork. Milk quality is consistent and standardized. This visual summary highlights strengths on both sides. India has a large farmer base, cooperative model, low-cost production, and strong local knowledge. Developed countries excel in advanced technology, complete cold chain, strict quality standards, and high efficiency. India can adopt automation, cold chain expansion, and quality standards. Developed systems can learn resilience, sustainability, and community-based models from India. Finally, we come to the end of this session. Comparing tropical dairying systems helps us understand how improvements can be made in Indian dairy production. Thank you for learning with Muktichi. Keep learning and keep improving.